All right, we're back. We're going to do Fall 2020 Test 3, Part 4, Question 2. It's another mechanism question. And here we say there's only one product formed. Explain our choice. I prefer to do the mechanism first. And this is the oxymercuration reaction, the big clue being your mercury acetate here. And it's a reaction that's done in water. So there is lots of water around, and it's an ionic compound in water, and many of those dissociate as soon as you put them in water, and the pair of electrons goes from the bond to mercury and breaks off and ends up as a lone pair on the more electronegative oxygen. And it's okay to use that short form OAC, but we need to know that an AC is a CH3 attached to a carbonyl, and the O part of the OAC is the extra O that makes it an acetate. So that's one piece that broke off. The other piece that broke off is mercury with a second acetate still attached, and it doesn't ionize further. That's just the nature of this ionic compound, a single ionization. And now this is a alkenophile. It loves pi electrons between carbons. This reaction happens very quickly. And we make, in step 2, very monochromatic here. Step 2, we get a triangular intermediate. And it looks like this. And the key thing is we only used one arrow to make this next intermediate. And the mercury has bonds to both carbons simultaneously. They can't be real bonds. That would be 4 electrons. So in this case, they are partial bonds. And we'll put those in purple. Partial bond from carbon to mercury. These are not dashes. Do not confuse them with dashes. These are partial bonds. Even the pi bond is still partially there. So we have a triangle. It's not the best drawn triangle. I'll try to do better. Triangle. 3 partial bonds. Where's the plus charge now? It used to be owned solely by the mercury, and now it is shared by all 3 atoms. It's one reason why this reaction's fast. The plus charge burden is shared by many atoms. It spends a little more time near this tertiary carbon than it does near the secondary, but just put it in the middle to be safe. Now, how do we get the OH on here? Clearly, every product has an OH on one of the carbons. And the same way we put the OH on there, well, we didn't do it here. We did it this morning, didn't we? We did it this morning. We put water, OH on a carbon using acid catalyzed hydration and the vicinal halohydrin formation. The reaction is similar to this one. In this one, okay, I don't even know what happened there. There we go. The water, which is present in very large amounts, it's the solvent, does a backside attack on the carbon that spends more time with the plus charge. That's just a fancy way of saying the carbon with more hyperconjugation. And we're going to be using that in our explanation. And whenever you do a backside attack on a triangle, you end up with the new bonds that are anti, well, the new bond is anti to the one you're breaking. So if the water came in from behind the triangle, then the mercury got pushed outside. And this time, these bonds here, that's a real covalent dash bond. And we call this anti-stereoselectivity here. And the mercury's still on there, don't get me wrong. And yes, O with the 3 bonds is an oxonium, which has a pKa of -3. And we're going to make this into product number 2, although you're going to question me, say, why doesn't it look like product number 2? This mechanism actually makes the enantiomer of 2. I could have got to 2 if I had this is a wedge and this is a dash. But you're going to make equal amounts of this one and the enantiomer. You don't have to write plus enant on your test. The enantiomer would have a wedge here and a dash here. And that's the end of that story. And why did I pick acetate to make the acid-base reaction happen in step number 4? The reason's explained in several videos, and the textbook. This is our best base. It's better base than water by a lot. pKb here is 14 minus 5 because you're making acetic acid right here. pKa 5, you don't have to show that, but here it is, free of charge. So the pKb here is 9. pKb of water is 14 minus -3 is 17. That is a billion times or 100 million times less basic than acetate. And we're not done. We have to, we circled our product. Copy the only product is formed. We need to explain our choice. Now the choice has got a lot of points for the explaining your choice. You got to explain why one's a wedge and one is a dash. So we'll do that first. This is the part of the answer to A. Anti-stereoselectivity caused by backside attack and I put my explanation over here, but really the reason I put it here is I see that one's a wedge, one's a dash. That's called anti, and the S looks like it's floating in space here. Stereoselectivity. And really, there's the anti-stereoselectivity. So what I'll do is I'll put a little asterisk here. Here's your backside attack right here. And the reason why we have the O on the more substituted carbon and the mercury on the less substituted carbon is another discussion entirely. So it's also part of A, but it's a separate discussion. H2O attacks the C that spends more time as a C+, which is a carbocation. And I need the magic word in here. You can put it in parentheses. Why? Because of hyperconjugation. So you're going to be putting hyperconjugation down a couple times on this test. So learn how to pretty much spell it. If you have a little mistake in there, I'll forgive you. But try to get close, okay? And there you have it. You've got your explanation. No labels. You'll only be labeling your first reaction like we did in the previous video with the Lubnus and the Habibis. Okay, and is that it for this one?
Yeah.
Any questions?
No, not really.
Okay.
I need to practice these ones more.
All right, we'll come back for another session. Do you think you got something for me?
I can't think of anything. If you
So
think
we
there's
won't come back.
we could do,
I
then
think
that's
we're good to
fine.
go because this will keep everybody busy. This gets you about halfway through chapter 6 if you can get to this one. So students will look at it, say, "Oh, okay, yeah, I got some reading to do, got some things to do," and try to get past this before we finish the week.
Professor, I have
Yes.
like an unrelated question to this, so I don't know if like you're probably gonna cut this out, but like it's about lab.
Oh, let's stop the share. And I'll just I think we can jump right back. It won't take long to render. Can you wait a couple minutes while it
Yep.
renders, and I'll just come back and we'll talk.
Yeah, that's completely fine.
All right.